Hello everyone. Welcome back to our journey through relations and functions. Today, we are going to explore something truly fundamental in mathematics, the Cartesian product of sets. Let's begin with a simple, clear example inspired by your NCERT textbook. Imagine you have two sets right in front of you, set A, which has two colors, red and blue. Set B, which has three objects, bag, coat, and shirt. Now, think about all the ways you could pair one color with one object. Each unique pairing forms what mathematicians call an ordered pair. Here are all the possible pairs you can create: red, bag, red, coat, red, shirt, blue, bag, blue, coat, blue, shirt. This entire collection is what we call the Cartesian product of set A and set B. In mathematical language, we write it like this: a cross B equals the set of all ordered pairs A, B, such that A belongs to A and B belongs to B. By creating all these pairs, you are laying the groundwork for understanding how sets connect and how relations begin. Now, let's define the Cartesian product in a precise and simple way. Imagine you have any two non-empty sets, which we call A and B. The Cartesian product of these sets is written as A times B. You can read it as A cross B. This product is nothing more than the set of all possible ordered pairs where the first element of the pair comes from set A and the second element comes from set B. Mathematically, it looks like this: A cross B equals the set of all ordered pairs written as A, B, such that A belongs to set A and B belongs to set B. One very important thing to remember: the order of elements matters a lot. For example, red, bag means something completely different from bag, red. They are not the same pair because the positions of the elements have changed. And this is exactly why we call them ordered pairs, because the sequence determines their meaning. This idea of order is the foundation for understanding relations and how sets interact. You might be wondering, how many pairs can we actually create when we form a Cartesian product? Let's make it simple. If set A has P elements and set B has Q elements, the total number of ordered pairs is given by this formula: number of pairs equals P multiplied by Q. Let's apply this to our example. Set A has two elements, red and blue. Set B has three elements, bag, coat, and shirt. When you multiply them, 2 multiplied by 3 equals 6. So there are 6 distinct ordered pairs in total. This simple counting principle is a powerful shortcut to see how large your Cartesian product will be. And here's something important to remember: if either set is empty, meaning it has no elements at all, then the Cartesian product will also be empty. No elements to pair means no pairs at all. This basic idea helps you measure and understand the size of Cartesian products quickly and confidently. Let's see how the Cartesian product works in a real-world scenario, like generating vehicle license codes. Suppose we have a set of states: set A equals open curly bracket DL, MP, KA, close curly bracket. These represent Delhi, Madhya Pradesh, and Karnataka. Now, we have another set of numbers: set B equals open curly bracket 01, 02, 03, close curly bracket. To create all possible license codes, we take every element from set A and pair it with each element from set B. That gives us 3 elements in set A times 3 elements in set B equals 9 unique pairs. Spelled out as 3 multiplied by 3 equals 9. Each pair, like open bracket DL, 01, close bracket, forms part of a license code. This is a perfect example of the Cartesian product in action, organizing data by creating every possible combination between two sets. Let's take two simple sets, Set A contains the numbers 1 and 2. Set B contains the numbers 3 and 4. To form all possible combinations, we pair every element from set A with each element in set B. This gives us the following ordered pairs: open bracket 1, 3, close bracket, open bracket 1, 4, close bracket, open bracket 2, 3, close bracket and open bracket 2, 4, close bracket. In total, we have 4 pairs because 2 elements in set A times 2 elements in set B equals 4. This process is called the Cartesian product, and it shows every possible combination between 2 sets. Let's now explore ordered triplets, a powerful extension of Cartesian products. When we write a cross A, we are forming all possible ordered combinations of 3 elements, each chosen from the same set A. For example, suppose set A contains 2 elements, 1 and 2. Then, the total number of triplets you can form is 2 times 2 times 2, which equals 8. That gives us 8 unique ordered triplets. These triplets help us represent positions in 3-dimensional space, just like ordered pairs help us in 2 dimensions. So, whether you're plotting a point in 3D geometry or defining a pixel in computer graphics, ordered triplets play a vital role in building both 2D and 3D coordinate systems. Let's explore some important properties of Cartesian products and ordered pairs. First, the total number of ordered pairs you can form between 2 sets A and B is found by multiplying their sizes. If set A has P elements and set B has Q elements, then the total number of pairs is P multiplied by Q. Second, order matters in Cartesian products. The Cartesian product of A and B is not equal to the Cartesian product of B and A. For example, the pair 2, 3 is not the same as 3, 2. Third, if you take the Cartesian product of any set A with the empty set, the result is also an empty set. That is, A multiplied by the empty set equals the empty set. No pair can be formed if one set has no elements. Finally, an ordered pair AB is equal to another ordered pair XY only if the first elements are equal, that is, A equals X, and the second elements are also equal, that is, B equals Y. Great work today. You've learned so much about Cartesian products. You now know how to create, list, and count all the possible pairs and triplets between sets. This is a key step in defining relations. In our next lesson, we'll see exactly how these pairs become relations and how relations set the stage for understanding functions. Keep exploring, keep practicing, and stay curious. I'll see you in the next video where we connect all these ideas together.